In the current discussion, we have talked about Minkowski four-dimensional space. According to the relativity theory, the space and time coordinates depend on one another. Therefore, in the special theory of relativity, predictions are made in a four-dimensional space called Minkowski space. Usually, we are using x, y, and z as space coordinates. To specify a system, we need these three coordinates. In addition to this, we may introduce a fourth coordinate, time. If observations are made with the help of all these four coordinates, such a space is called as Minkowski's four-dimensional space. Because the position coordinates x, y, and z, as well as the time, are depending on each other. In Minkowski's space, x, y, and z, usually x is replaced by x1, y is replaced by x2, and z is replaced by x3. These coordinates x, y, and z specify the position, and the fourth coordinate x4 is equal to ICT. The fourth coordinate is chosen as imaginary instead of simply t, because the term s square is equal to x square plus y square plus z square minus c square t square is invariant under Lorentz transformation. The value of s square in rest frame is this much. In the moving s dash frame is this much. Anyway, the value of s square in the rest frame should equal the value of s dash square in the moving frame. Here, x1 is our x, x2 is our y, x3 is our z. So, x square means x1 square, y square means x2 square, z square means x3 square. Then x4 square is I square, c square, t square. The value of I square is equal to minus 1. Therefore, we may get minus c square, t square. In this way, the value of x4 is considered as ICT. Here x dash, y dash, z dash, and ICT dash are the four coordinates in the frame S dash, while x, y, z and ICT are those in S frame. Because S square is invariant, a Lorentz transformation can be thought of as a rotation of coordinate axis x, y, z at ICT in space-time. The rotation of coordinates will provide the Lorentz transformation equation. We have to confirm this. To prove this, consider the rotation of x1, x4 plane through an angle theta. See, this is x1, this is x4. If you rotate x1 through an angle theta, we can get the new position x1 dash. If x4 is rotated through an angle theta, we can get the new position x4 dash. Consider a point P at a distance r from the origin. So, this line OP is our R, which makes an angle pi with this line OX1 dash. This is the new position of OX1. If you rotate OX1 through an angle theta, we can get this OX1 dash. Now, the point P makes an angle pi with this OX1 dash. Here, this is our x4, this is x4 dash. OA is our x1, then OB is our x1 dash. Now take this triangle. POB. Consider right triangle POB. POB. Here the angle is pi. Sin pi. This is 90 degree. So this is hypotenuse R. Sin pi equal to opposite side by hypotenuse. It is PB divided by OP. The opposite side PB is x4 dash and the hypotenuse is R. Then we can write x4 dash equal to R sin pi. The same triangle POB cos pi equal to adjacent side, that is OB divided by hypotenuse OP. This OB is our x1 dash. If you subject x1 to theta d rotation, we can get this OB x1 dash. X1 dash divided by R. Now x1 dash equal to R cos pi. Now consider the triangle POA. Consider a right triangle POA. Here sin pi plus theta equal to POA angle is pi plus theta. Sin pi plus theta equal to, this is 90 degree. Then opposite side, this is hypotenuse. PA divided by OP. PA by OP. Then this PA is our x4. x4 by R. Then x4 equal to R sin pi plus theta. This is equal to sin pi cos theta plus cos pi sin theta. Sin A cos B plus cos A sin B. This is R sin pi cos theta plus R cos pi sin theta. This is x4. Then the value of R sin pi is x4 dash. So instead of this R sin pi, we can put x4 dash. And R cos pi is x1 dash. Then the above equation is modified as x4 equal to x4 dash cos theta plus x1 dash sin theta. Keep this as equation 1. Now from the triangle POA, find the value of cos pi plus theta. Cos pi plus theta. See here, cos pi plus theta is adjacent side by hypotenuse. OA divided by OP. OA divided by OP. OA is our x1, OP is our R. Therefore, x1 equal to R into cos of pi plus theta is equal to R into cos A cos B minus sin A sin B. This is R cos pi cos theta minus R sin pi sin theta. And R cos pi then R sin pi. R cos pi is our x1 dash. This is x1 dash. R sin pi is our x4 dash. This is x4 dash. Therefore, x1 equal to x1 dash cos theta minus x4 dash sin theta. This is equation number 2. Now write down these two equations separately. x4 equal to x4 dash cos theta plus x1 dash sin theta. This is equation 1. Then x1 equal to x1 dash cos theta minus x4 dash sin theta. This is equation number 2. Now multiply equation 1 on both sides by cos theta. Cos theta into x4, which is equal to x4 dash cos square theta plus x1 dash cos theta sin theta. This is equation 3. Now multiply equation 2 by minus sin theta. This is 1 into cos theta gives then 2 into minus sin theta gives minus sin theta x1 equal to minus sin theta x1 dash cos theta then minus x4 dash sin square theta, minus to minus plus, because we have multiplied with minus sin theta. This is equation 4. Now 3 plus 4 gives cos theta x4 minus sin theta x1 equal to x4 dash cos square theta plus x4 dash sin square theta. This is in positive sign, this is in negative sign. So cancel each other. Cancel out. This is cos theta x4 minus sin theta x1, which is equal to x4 dash, because if you take x4 dash outside, this is cos square theta plus sin square theta. Then x4 dash equal to cos theta x4 minus sin theta x1. We can get the value of x4. Now multiply equation 1 by sin theta. Equation 1 into sin theta gives 1 into sin theta means, say this is 1. Sin theta x4, sin theta x4 equal to sin theta x4 equal to x4 dash sin theta cos theta, x4 dash sin theta cos theta plus x1 dash sin square theta. Say this is equation 5. Now multiply equation 2 into cos theta. x1 cos theta, that is cos theta x1, which is equal to x1 dash cos square theta minus x4 dash sin theta cos theta. Say this is 6. Now 5 plus 6 gives sin theta x4 plus cos theta x1, which is equal to, this is in positive sign, this is in minus sign, so cancel out. x1 dash sin square theta plus x1 dash cos square theta is sin theta x4 plus cos theta x1 equal to x1 dash into sin square theta plus cos square theta. This is equal to 1. Therefore, x1 dash equal to sin theta x4 plus cos theta x1. Now, this is second equation. So this is A, this is B. Now using these two, x1 dash, x4 dash equal to the value of coefficient of x1 is cos theta, coefficient of x4 is sin theta in terms of x1 dash. Now go to our x4 dash, the coefficient of x1 is minus sin theta, minus sin theta. Then the coefficient of x4 is cos theta. Into x1, x4. Now, write down the inverse of this equation. Inverse of the above equation is x1, x4 equal to cos theta. Cos of minus theta is cos theta. This is minus sin theta. Sin of minus theta minus sin theta. Then this is plus sin theta. This is cos theta into x1 dash, x4 dash. In the above equation, if x1 dash equal to 0, you can write x1, x4 equal to 0 into cos theta 0, then minus sin theta into x4. 0 into sin theta 0 plus cos theta x4. From this we can write x1 equal to minus sin theta x4, x4 equal to cos theta x4, x1 by x4 equal to minus sin theta by cos theta, that is equal to minus tan theta. This x4 x4 cancelled out. And tan theta equal to minus x1 by x4. This is minus x1 divided by the value of x4 is ICT. Now we can write this distance by time as velocity. Therefore, this is minus V by IC. Then tan theta equal to IV by C, because I by IV, your I square is minus 1, minus and minus plus, so IV by C, this is tan theta. Now, from this we can write sin theta equal to IV by C whole divided by root of 1 minus V square by C square. Then cos theta equal to 1 divided by root of 1 minus V square by C square. If you want to find tan theta, sin theta by cos theta is tan theta. Sin theta is I by C divided by root of 1 minus V square by C square divided by cos theta. That means into root of 1 minus V square by C square. Then we can get tan theta equal to IV by C. Now come to the first equation, first matrix. Say this is the first matrix. From this matrix, x1 dash equal to cos theta x1 plus sin theta x4 plus sin theta x4. And the second equation is x4 dash equal to minus sin theta x1 minus sin theta x1. We have had the two equations at the beginning. Minus sin theta x1 plus cos theta x4 plus cos theta x4. Now take the first equation, x1 dash equal to cos theta. The value of cos theta is 1 divided by root of 1 minus v square by c square, this into x1 plus the value of sin theta is I into v by c divided by root of 1 minus v square by c square into x4. Then the x4 is ICT. So x1 dash equal to 1 divided by 1 minus v square by c square inside the root x1 plus iv by c into ICT. x4 is ICT divided by root of 1 minus v square by c square. Then x1 dash equal to, take this 1 minus v square by c square as a common term into x1, say this c cancelled out, I into I square is minus 1, so x1 minus vt divided by root of 1 minus v square by c square. x1 dash equal to x1 minus vt divided by root of 1 minus v square by c square is the first transformation equation, Lorentz transformation equation. X dash equal to x minus vt divided by root of 1 minus v square by c square. Then y dash equal to y, z dash equal to z. Y dash equal to y, z dash equal to z. Now come to the second equation. x4 dash equal to minus sin theta x1 plus cos theta x4 plus cos theta x4. This is minus iv by c root of 1 minus v square by c square, which is the value of sin theta into x1 plus cos theta value is 1 minus v square by c square inside root into x4. This is ICT. Now take out the term IC divided by root of 1 minus v square by c square as a common term. IC divided by root of 1 minus v square by, so this t is present minus. We have taken out IC. I is present in the numerator, but not c term is available here. So this is v divided by c square into this x1. This is x4 dash, which is IC t dash, that is x4 dash. Put IC divided by root of 1 minus v square by c square into t minus v by c square into x1. If you simplify this, we can get, see here, IC cancelled out, t dash equal to t minus v by c square into x1 whole divided by root of 1 minus v square by c square. This is the final equation. In the Lorentz transformation equation, we know that t dash equal to t minus v by c square into x whole divided by root of 1 minus v square by c square. By the way of rotating the x1 x4 plane, we can get all the 4 Lorentz transformation equations. That's all about the Minkowski's 4-dimensional space.